Thank you very much. I am presenting another talk. Actually, this was supposed to be presented by my wife, but we came from minus 14 degrees Celsius from Uppsala, Sweden, to here 12 or 18 degrees. Then it is very nice, and we never use ice in drinking water, but she did it, and she has sore throat. So in fact, she ordered me to present. She has created these slides. So again, we have the same kind of support and same kind of organization, but another problem in the military is sleep deprivation. And sleep deprivation is very serious in our military and also many other professions like pilots, and it can lead to judgmental error. So what we are concentrated about that what is happening on sleep deprivation on brain. That's number one thing. And you know that our soldiers, they have to fight, and of course also at high altitude, they have sleep deprivation, they can get injury. So it is a compound effect on their brain pathology. So these are the basic aspects we are working in this area. And as you can see that first, we have nothing to disclose. And second thing is that all my conclusions and presentation is my sole opinion. It has nothing to do with US government or any organization we are working with. So sleep deprivation is very common, and we have shown previously that the sleep is the subject of serotonin neurotransmitter. So if we try to block serotonin receptors, the problem is that serotonin has more than 7 kind of receptors and also receptor subtypes. So the point is that we have to choose some drugs that could be working. So we have shown that ondansetron can prevent brain pathology in sleep deprivation alone. And as you can see, that traumatic brain injury can produce many kinds of changes in our brain, including neurotransmitters, and we worked a long time on serotonin. Here we can see that the leakage of blood-brain barrier is quite pronounced in all kinds of brain diseases and including trauma. So whenever we have leakage of proteins, it produces edema and affects the neurons and glial cells. So this is a normal life of our soldiers in the battlefield. They have very less time to sleep, and still they have to be attentive. So this creates real problems. One unclassified data shows that even if you have sleep less than 6 hours, then you can't even calculate simple mathematics. And this is progressively increasing up to 72 hours. And these are the brain injury data, unclassified. Of course, this is old, but that's all we have at the moment. And you can see that this brain injury in males and females, the most productive time is 15 to 17 years and 18 to 24 years in both. Of course, the females, they have a little less than men. And this is another cartoon showing that after concussive injury, there is a lot of changes in memory function and motor planning. So the point is that all our cognitive functions are altered. We have a model of concussive head injury in our laboratory that we have developed this. It produces an impact of 0.224 Newton on the skull surface. And it works like clinical situations because like counter-coup injury. So if we apply this weight drop on right side, we have more injury on left side. And this was one of the technology presented after sleep deprivation and head injury and treatment with alpha MSH together with cerebrolizin. And we were surprised that my wife got this top 15% technology award in National Innovation Summit last year. The another thing we are working on, try to educate people on the nano delivery and gene delivery using nanotechnology, because this is a large program of the United States of nanotechnology. And this was the Springer book released last year. And also this is International Review of Neurobiology, that nanomedicine in CNS injury and repair. So at least people can understand that nanomedicine is going to be an important part in our medicine in future. This was the paper published in Molecular Neurobiology in 2015, where we have shown that sleep deprivation alone can induce brain injury. So here we wanted to see that how combination of different kind of drugs, in this case 5-HT6 antagonist, together with cerebrolizing, because one can potentiate the effect of drug, one can also neutralize the effect of another good drug. So this is the model we have chosen for inverted flower pot model of sleep deprivation. And here you can see that sleep deprivation can induce brain injury depending on time exposed. 12 hour, 24 hour and 72 hours, progressive increase. And the other thing is that if the rats were intoxicated with certain engineered nanoparticles, there is much more damage in this case. Then we have used ondansetron, and we can produce neural protection. But when we have given nanowired ondansetron, its dose is less and it is much more neuroprotective. This is the example of concussive head injury, and you can see that left side is much more damaged at electron microscopy. The same thing happens with light microscopy. When we have combined sleep deprivation with head injury, you can see that cell damage were much more higher in both sides. Then we have combined with titanium nanowired cerebrolizing, and of course we use alpha MSH at that time because it is very important in sleep, and you can see that this is well neuroprotection, and it is confirmed also at electron microscopy, the same combination. So now, in order to find out suitable combination, we have a number of drugs that we combine together to see that the result is potentiated or neutralized. So in this case, we have used 5-HT6 receptor antagonist SB399-885, and I'm showing you the results here. And you see that in control, we have higher level of blood-brain barrier leakage, edema formation, neuronal damages, and even increase in serotonin. A combination of sleep deprivation and concussive head injury has aggravated all these parameters. Interestingly though, when we have used titanium nanowire cerebrolizing together with 5-HT6 antagonist, all values were significantly reduced. Now we are comparing that whether alpha MSH is superior or 5-HT6 antagonist or some other drugs are superior. But these studies are still underway. I'm showing here one example where the 5-HT6 antagonist alone were given nanowired, and in the other side we have used combination with cerebrolizing, and as you can see that the combination works much better than this 5-HT6 antagonist alone. So the point is that although the drug has some neuroprotective effects, but it can enhance or it can be increased its neuroprotective capability if we combine with cerebrolizing and both nanowired. So we can say that a combination of cerebrolizing and 5-HT6 antagonist may have better neuroprotective abilities if they were given using nanowire technology. We have also given without, and there is some neuroprotection, but it is not that big enough as compared to in these situations. And of course we have lots of support from governmental agencies, US government, Swedish government, and even Chinese government is now supporting some of the traditional Chinese medicines to give an nanowire and see in different models. Of course we have support from various organizations, and US government support is quite impressive. We have different collaborators all around the world, and as I told you earlier, I am from Uppsala University, and I thank you for your kind attention and look forward to seeing how we can improve these results in future. Thank you very much.
We have a few minutes for questions. If there are any questions.